In the annals of scientific history, few names shine as brightly as Galileo Galilei. Born in Pisa, Italy in 1564, Galileo was a true polymath, excelling in mathematics, physics, astronomy, and engineering. His insatiable curiosity and relentless pursuit of truth challenged the established order and revolutionized our understanding of the cosmos. Galileo's life was marked by groundbreaking discoveries, fierce opposition from the Catholic Church, and an unyielding commitment to scientific inquiry. He dared to question the prevailing geocentric model of the universe, which placed Earth at the center, and embraced the heliocentric model, advocating for the Sun's central position. This essay delves into the life and work of this scientific icon, exploring his major contributions to astronomy, his conflicts with the Church, and his enduring legacy as the father of modern science. Galileo's story is a testament to the power of observation, the importance of questioning dogma, and the transformative potential of scientific thought. Galileo Galilei was born into a world steeped in tradition and authority. The son of a musician and music theorist, young Galileo displayed an early aptitude for mathematics and mechanics. Initially, he pursued a medical education at the University of Pisa as desired by his father. However, Galileo's true passion lay elsewhere. He was captivated by the works of ancient Greek mathematicians and philosophers, particularly Euclid and Archimedes. His fascination with geometry and mechanics led him to abandon medicine and devote himself fully to the study of mathematics. At the age of 25, Galileo secured a position as a mathematics professor at the University of Pisa. It was during this time that he began conducting experiments on motion and gravity, challenging the long-held Aristotelian views that had dominated scientific thought for centuries. Galileo's early work laid the foundation for his future breakthroughs and set the stage for his revolutionary discoveries in astronomy. While Galileo did not invent the telescope, he significantly improved upon its design and, more importantly, was the first to use it systematically for astronomical observations. In 1609, Galileo learned of a new invention from the Netherlands, a spyglass that could magnify distant objects. Intrigued by its potential, Galileo set about constructing his own telescope. Through meticulous grinding and polishing of lenses, he created a telescope far superior to any that existed at the time. His initial telescope could magnify objects about 3 times. Galileo continued to refine his designs, eventually achieving a magnification of around 20 to 30 times. This technological leap enabled him to peer into the heavens with unprecedented clarity, revealing celestial wonders that had remained hidden from human view for millennia. Galileo's telescope became his window to the cosmos, ushering in a new era of astronomical observation and forever changing our understanding of the universe. With his powerful telescope, Galileo embarked on a series of groundbreaking observations that would challenge the very foundations of the geocentric model of the universe. The prevailing view at the time, supported by both the scientific community and the Catholic Church, held that Earth was the stationary center of the universe, with all other celestial bodies revolving around it. Galileo's observations, however, began to paint a very different picture. One of his most startling discoveries was the observation of craters and mountains on the surface of the Moon. This contradicted the Aristotelian belief in the perfect, unchanging nature of celestial bodies. He also observed sunspots, blemishes on the surface of the Sun, further challenging the idea of celestial perfection. These observations, along with his discovery of the phases of Venus, provided compelling evidence that the Sun, not Earth, was the center of the solar system as proposed by the heliocentric model of Nicholas Copernicus. Section 5, Galileo and the Moon. A closer look at our celestial neighbor. Turning his gaze towards our celestial neighbor, the Moon, Galileo made a series of groundbreaking observations that would forever alter our understanding of this celestial body. Through his telescope, he observed the Moon's rugged terrain, marked by craters, mountains, and vast plains. This was a significant departure from the Aristotelian view of the Moon as a perfect, smooth sphere. Galileo meticulously sketched his observations, creating detailed drawings of the lunar surface that revealed its true nature as a world with its own unique topography. He even estimated the height of some of the lunar mountains, demonstrating that they were comparable in size to mountains on Earth. These observations provided compelling evidence against the prevailing belief in the fundamental difference between the celestial and terrestrial realms. The moons of Jupiter, evidence against geocentrism. Galileo observed 4 celestial bodies orbiting Jupiter. In January 1610, he saw 4 points of light near Jupiter. These points changed position, indicating they orbited Jupiter. Galileo named them the Medicean stars, later known as the Galilean moons. This discovery supported the heliocentric model, challenging geocentrism. Section 7. The trial and condemnation, a clash of science and dogma. Galileo's groundbreaking discoveries and his outspoken advocacy for the heliocentric model brought him into direct conflict with the Catholic Church. The Church, firmly rooted in the geocentric view, considered Galileo's ideas heretical and a threat to its authority. In 1616, the Church issued an edict declaring the heliocentric theory false and contrary to Scripture. Galileo was ordered to abandon his support for the Copernican system. Despite the Church's warning, Galileo continued to defend the heliocentric model in his writings. In 1632, he published his Dialogue Concerning the Two Chief World Systems, a masterpiece of scientific literature that presented a compelling case for the heliocentric model. The book's publication proved to be a turning point in Galileo's relationship with the Church. He was summoned to Rome to face the Inquisition, charged with heresy and suspected of holding heretical views. Section 8, House Arrest and Continued Work, The Indomitable Spirit. Following a trial that captivated and divided Europe, Galileo was found vehemently suspect of heresy by the Inquisition in 1633. Forced to recant his heliocentric views under the threat of torture, Galileo was placed under house arrest for the remainder of his life. Confined to his villa near Florence, Galileo's spirit remained unbroken. Despite the restrictions placed upon him, he continued his scientific work. During this period, he wrote his final and arguably most important work, Two New Sciences, which summarized his groundbreaking work in physics, particularly in the areas of motion and mechanics. This book, smuggled out of Italy and published in the Netherlands in 1638, solidified Galileo's legacy as a scientific giant. Even under house arrest, Galileo's thirst for knowledge and his commitment to scientific inquiry never waned. Section 9, Galileo's legacy, the father of modern science. Galileo Galilei's contributions to science are immeasurable. He is considered the father of modern astronomy, observational physics, and the scientific method. His pioneering use of the telescope revolutionized our understanding of the cosmos, revealing celestial wonders that had been hidden from human view for centuries. His meticulous observations and groundbreaking discoveries, such as the phases of Venus and the moons of Jupiter, provided compelling evidence for the heliocentric model of the solar system, challenging the long-held geocentric view and paving the way for the acceptance of a sun-centered universe. Galileo's emphasis on observation, experimentation, and mathematical analysis laid the foundation for the scientific method, a systematic approach to acquiring knowledge that has become the cornerstone of modern science. His unwavering belief in the power of reason and his willingness to challenge established dogma continue to inspire scientists and thinkers to this day. Section 10. Conclusion, the enduring impact of a scientific rebel. Galileo Galilei's legacy extends far beyond his scientific achievements. His life and work serve as a timeless reminder of the importance of intellectual freedom, the power of observation, and the need to question accepted truths. His courage to challenge the prevailing scientific and religious dogma of his time paved the way for future generations of scientists to explore the universe and unlock its secrets. Galileo's story is a testament to the indomitable spirit of human curiosity and the transformative power of scientific inquiry. Centuries after his death, Galileo's name continues to resonate as a symbol of scientific progress, intellectual courage, and the enduring quest to understand our place in the cosmos. His legacy continues to inspire us to look beyond the confines of our world and to explore the vast universe that surrounds us.